Hello everybody and welcome to today's Mqtt Masterclass. Just going to click through now and have a look at our agenda for today. So this presentation is being recorded and you will all automatically receive a copy of the recording at the end of the session. There will be a Q&A session at the end. So if you have any questions, please enter them into the toolbar on your GoToWebinar application, and we'll get to those at the end of the session. Just to give you a run through of what we're covering today, so there'll be an introduction to MQTT and IoT from Bruce Jackson, and then Simon Johnson will talk to us about the MQTT standardization and history and our part on the new standards committee. I will then take you through an MQTT and Mqtt Sn tutorial where we'll have a quick look at the way that the MQTT client and broker work together, topic structures and so on. And then Hamid Siassi will cover a section on a deep look at the power benefits of Mqtt Sn and how that compares to other protocols that are available. And then we'll have a quick wrap up at the end. So without further ado, I will hand over to Bruce, who'll give you an introduction to MQTT and its place in IoT.
Thanks very much, Nick. Next slide, please. So let me say a few words about MQTT. Why MQTT? Well, MQTT is a protocol that really has become probably the dominant communication method or protocol for IoT. It originates back from a research project that was done at IBM some time ago, but has now become something that's standardized under the OASIS standards group umbrella, and Simon will talk more about that later on in this presentation. MQTT is then evolved into Mqtt Sn, which is designed to optimize further for smaller devices, and again, both Nick and Simon will talk a bit more about that as we go through this presentation. Next slide, please. Just to say a few words about u-blox. u-blox has been very active in the MQTT space, and we have three primary products that we offer in this area: MQTT Anywhere, MQTT Here, and Now. And one of the things that makes MQTT attractive is that there is a separation between the protocol itself and the bearer. There are other protocols that people talk about when they think about small, lightweight devices communicating perhaps to a back-end system. For example, things like lightweight M2M. But lightweight M2M is really originates from the cellular space. One of the things that's nice about MQTT as a protocol is that it's available on any radio network. And in fact, the three that you see here, Anywhere, is our implementation of that over cellular, actually Mqtt Sn over cellular. MQTT Now is really over regular IP, so typically Wi-Fi or Ethernet. And MQTT Here is bound to LoRaWAN. And the interesting thing is, of course, you can mix and match those together to build a solution. And from the back-end perspective and your information architecture point of view, you're able really to design one solution that will work across all of those different network types and actually have them interoperable between that. So you can match the kind of radio networks to solve the customer solution without necessarily having to change your information architecture, which is quite attractive. Now, in today's session, Simon's going to talk to us, as Nick mentioned, a bit about the MQTT standards evolution. Simon's an expert in that area and now has been working on in the OASIS group for that for some period of time. And then Nick and Hamid have been involved in implementing MQTT-based solutions for customers for many, many years now, and so they can provide some really good information and knowledge on those subjects. Do feel free in the panel, the questions panel, to add questions as we go along in the session. We have a Q&A session at the back end of this presentation where we'll try and answer as many of the questions as we can, and hopefully you'll find it an enjoyable time. With that, I'm going to hand over to Nick.
No, you're not. You're going to hand over to Simon. Thanks, Bruce. Hi, folks. My name's Simon Johnson, and I work as principal engineer in the u-blox ThingStream team. I've also had the privilege of representing u-blox as a contributor member on the core Mqtt technical committee and now as co-chair of the Mqtt subcommittee, of which I'll talk a little bit more about in a bit. But first, I'll give a bit of context to Mqtt by quickly summarising its history. So Mqtt was invented by Dr. Andy Stanford Clark of IBM and Arlen Nipper from Arcom, which is now Eurotech, in the late 90s. It was initially solved to created to solve a problem that they had with an incumbent system, which was a pipeline monitoring system where the devices were polling to get and receive information, and the servers were becoming CPU bound, and this wasn't working. So the genesis of Mqtt was born. The initial principles they had were that it needed to have built-in reliability, be reliable, be industry agnostic. So that meant that the payload purposefully wasn't defined, the format of it, to allow it to be deployed to any number of different solutions. It needed to be efficient for use on low resource constrained devices, be network efficient to limit the use of expensive satellite links, and be simple. Small specification, a simple architecture to understand, everything to drive adoption. The results with this specification was published openly and with no restrictions on use, so that it could be implemented on devices of all types with no one supplier controlling the specification. And over time, implementing clients pressed the need for standardization of the specification to cement the open nature of it, and to allow them to commit to longer term projects. And to that end, IBM selected Oasis as the standards body due to their existing collaboration and their work with ISO and ANSI. Nick, if you just move this slide on, please. Oasis is a non-profit standards body founded in 1993 by a consortium of vendors collaborating on interoperability. They offer technical committees, open projects to manage your open source, foundations, and ISO advisory groups. And if you are interested in becoming involved in the committee or simply asking questions about MQTT or any other number of subjects, then do get in touch with either myself or the MQTT mailing list. Someone will always get back to you, and we take all suggestions very seriously, and they are discussed in depth. So the standardization process of MQTT began at Oasis in 2013, and that resulted in MQTT 3.1.1 being published in October 2014, which was then subsequently ratified by ISO. Work continued after that, and MQTT 5 was published in March 2019. This increment introduced scalability, improved error reporting, additional metadata, and better performance. Over the years to get to MQTT 5, the technical committee has been supported and sponsored by some great companies and individuals. And it's this collaboration between the companies that work in the industries that really know their stuff, which has helped MQTT become the de facto for IoT. Some of the companies like IBM, uBlocks ourselves, EMQ, TIBCO, Software Hive, Cisco, to name but a few, and individuals as well. So now that MQTT mature, there's a boom in the sensor devices from the IoT space, and that's led to a need for a variant of MQTT, which is targeted directly at low-powered devices, which need to limit the amount of time on processor and the time the radio stack is powered up, so potentially without the need for TCP/IP. And this is where Mqtt Sn comes in. So Mqtt Sn started life in 2008 with initial goal to support non-TCP based protocols for use on low bandwidth networks and constrained devices, which we call sensor networks. Mqtt Sn added the notion of aggregated and transparent gateways to handle connectionless sessions with the devices themselves, and they themselves manage the connection to a central broker. It also optimizes the message formats from MQTT, and the session lifecycle introduces the concept of disconnected sessions, allowing devices to essentially go to sleep and put their MCUs to sleep, which has huge power benefits. In 2016, uBlocks implemented a commercial MQTT Sn gateway connecting millions of sensor devices with our enterprise broker. We saw firsthand the benefits of using this protocol, and so did our customers, able to develop their solutions efficiently using this technology and simply as well. 2019, uBlocks joined the technical committee, and our goal at that point was to focus on getting SN standardized, much like the MQTT core protocol had been. And later that year, the subcommittee was formed with the goal to standardise Mqtt Sn 1.2 based on our use of it and other real-world feedback. So we've been undergoing a large consultation process and specification review, which is in its later development now, and that's been going on for the last year and a half. And had a lot of input from all over the industry, and we've made adaptations to the topic registration, sleep life cycle, publishing mechanisms and error reporting, with a view to further optimizing what 1.2 was. We've recently become co-chair of the subcommittee alongside Ian Craggs and Richard Copham of the main Mqtt technical committee, and our goal now is to really get to standardization probably in the first quarter next year, hopefully, so that we can see Mqtt Sn adopted and become synonymous with sensor devices going forward. So with that, I'm going to hand over to Nick. Thanks.
Thank you, Simon. So now we'll go ahead and have a look at how you use MQTT and some of its key principles. So looking initially at the infrastructure of the u-blox communication as a service offer, and here I'm just focusing on MQTT Now, which is the IP-based solution, and MQTT Anywhere, which is the cellular SN solution. So with Mqtt Sn, you can use this with any cellular modem, so you're not restricted to u-blox modules. Although with a couple of the modules, the R4 and the R5, there are built-in Mqtt Sn clients which have some benefits in terms of speed to market. But for every other module, we have a client SDK, very small footprint SDK, which runs alongside your application firmware. And this SDK deals with the SN protocol, communication into the gateway and onwards to the broker. In the case of MQTT Now, then they're often, again, native MQTT clients on many modems and Wi-Fi modules. And there are a whole load of third-party MQTT clients that you can use to then do that communication over TCP/IP. But where we most commonly see MQTT Now used is in the enterprise backend, where the enterprise systems have their own MQTT clients, which are able to connect and subscribe to our broker and receive messages that the clients are publishing. For enterprise systems that don't have MQTT clients, we have what we call the data flow manager, which is a visual drag and drop programming interface, which has connectors for a number of different protocols and backend systems to allow you to get data out to the enterprise where MQTT isn't used. So let's have a look at the role of the MQTT client and the MQTT broker. One of the main principles to consider when you're looking at MQTT for the first time is to not think about clients and servers, but to think about clients and brokers. So an MQTT client is anything. It could be a microcontroller right up to a fully fledged enterprise server that's running an MQTT library and is then connecting to a broker over any kind of network. MQTT clients can publish and subscribe, so there's bidirectional communications, and messages are published to topics rather than being sent to specific things, specific devices. So think of MQTT topics like an email inbox or an address to send a message to, which other clients can then access and pull the information out. So clients receive messages by subscribing to topics on the brokers and publish messages to those same topics. The MQTT broker is responsible for handling authentication. It manages the connections and sessions and subscriptions, and it's responsible for receiving all of the published messages and then delivering them on to whoever is subscribed to those topics. It will also handle queues of messages for subscribed clients to be delivered according to the agreed quality of service that the message was published on. And we'll talk a bit more about quality of service and how that plays a factor in your message publishing a little bit later on. So connections are always made between a client and a broker. As we said, clients cannot connect directly to each other. They send a connect message to the broker. The connection then responds back with an acknowledgement, and then everything is set up. You must have with MQTT a connection in place in order to publish using the quality of services 0, 1 or 2, and also indeed to subscribe to any topics. There's usually, in terms of that connection, a client ID, username and password, and the client can only have one connection with the broker at any time. So that client ID, which the client connects with, is unique in terms of that session. If you try and connect another client using the same ID, then the broker will kick the first one off and open up a new connection for the new client ID. So something quite important to think about when you're getting started with MQTT. A lot of customers sort of run into this trap where they use the same client ID on multiple clients and can't work out why their connections keep getting dropped. One of the parameters on a MQTT connection is the clean session flag. This clean session allows you to start completely fresh with your client with no existing subscriptions or messages in the queue. If you connect with clean session set to false, the broker will maintain any subscriptions that were already there for the client and will deliver any queued messages that have come in while that client was away. With clean session set to true, the broker will purge all of those messages and subscriptions when the client connects. So again, very important when you're first getting going to make sure you have the correct clean session flag on your connection. In addition to that, there's the keep alive setting. This defines the period of time that the connection will remain in place with the broker without either side sending a message. While a client is connected or in that connected state, the broker will immediately deliver any messages that are published to topics that the client is subscribed to. So you need to make sure that in cases where your connectivity is perhaps volatile, as in with mobile comms, that you keep that keep alive to a minimum, and when you're going away, when you've finished with your communication, that you disconnect so that the broker knows that you're not there anymore, to prevent any possible data loss. So let's have a look at what that really means in practice with connections and clean session flags. So here we have our ThingStream portal, which has all of my various different MQTT clients and things in it. I also have a little Java MQTT client, which Simon put together for us to help with testing. So I'm just going to fire that up and get it configured and ready to roll. So now I'm going to connect to the broker. I'm going to collect with a clean session just to make sure anything left over from previous sessions is gone, and I'll set the keep alive of 600 seconds. So that's now done. The client's connected, and if we look now here in the broker, we'll see that my client has now moved to a connected state. If I look in my activity tab, I've got no subscriptions, and my keep alive is set to 10 minutes. So now let's have a look at what happens with the clean session flag. So I'm going to do a subscription here to a topic, just a simple webinar topic. I'm going to subscribe to that with a quality of service of 1. So my subscription is now set up. If I look back here, I will see it's refreshed, and there's my subscription to the webinar topic. I can now disconnect from the broker. That will then move to a disconnected state. And now if I use this send test message facility in the portal, I can publish messages on behalf of different devices to topics on the broker. So I'm going to publish a message to the webinar topic. Send that with a quality of service once, just a simple hello world message. And if I send that now, we'll see that that message will now arrive in the queue for my Masterclass client. If I now go back to my client and reconnect, and I'll set the clean session flag to false this time, so no, I don't want a clean session, and I'll connect for the 10 minutes again. Client will now connect, And you'll see now that the queued message has been delivered, the publish has been received on the topic webinar, Quality of Service 1, with the message Hello World. The queued message is now, it's switched to in-flight and has now been delivered to the client. So let's disconnect now and try that again, but this time with the clean session set to true. I'll go back to here, send that message again, same message, hello world, to the webinar topic, Quality of Service 1. That will come through and arrive in the queue. I go back to my clients, connect. This time I do want a clean session. Set my keep alive. Now the client will move to a connected state, and we'll see that the queued messages have gone immediately to 0. There was no transition to in-flight. And if I look now, my subscriptions are cleared. So that's how the connect and the clean session flags operate. Let's just go in and disconnect that again. Get that all cleared up for later. So moving on then, let's have a look at topics. MQTT messages are published to topics, and the broker delivers messages to clients that are subscribed to that topic. And topics can be made up of one or more different topic levels separated by a /. In this example here, we have 3 topic levels. One to indicate the type of device, it's a sensor device. One to indicate the type of sensor which is sending a value, and one to indicate the next level of message. The topics are case sensitive, and they don't have to be pre-registered at the broker. So there's no need for the Mqtt broker itself to have any of this information. It's all set up when the client issues its publish and the other clients issue their subscribe commands. So topics are a really good way to organize your data as it's flowing through the network. And you'll see how this can become more useful as your use case sort of scales up. So imagine you have devices with several different sensors deployed across multiple sites. Now, of course, you can include all of that sensor information and site information in the payload and parse it when it arrives on the broker. Or you could, rather than do that, use topics. So that instead of including all of that additional data, you're just sending the raw data from the sensor as is required. So in this case, we've got sensors and then temperature for site 1. We've got sensors and vibration on site 2, sensors and water on site 1, sensors and light on site 1, level 3, and these topic structures can go as deep as you need them to. Now, as we said before, the MQTT clients don't directly connect to each other. They subscribe to the topics on the broker. And they do this by issuing the subscribe command, which the broker then responds to with an acknowledgement. And the client can decide the quality of service at which it wants to receive messages, which allows it to downgrade the quality of service of the original published message. And we'll talk about that a little bit more when we look in more detail at quality of service. When you're subscribing, you can also use wildcards. These can be really handy when you have kind of deep topic structures. There are 2 types of wildcard that you can use. One is the single level, which is noted by this plus symbol. And the single level wildcard replaces one topic level in that structure. So we think here, sensors, temperature, site 1. If we pop a plus in here in the middle for the temperature, then the wildcard would cover sensors soil, sensors water, sensors light, and then site 1 at the end. So anything in the middle there with a plus would be subscribed to. There are also multi-level wildcards, and this is shown by the hash symbol. So in this case, I'm subscribing sensors/hash. This basically means that anything after this slash will be received. So sensors/soil/site 1, soil/site 2, temperature site 12, light site 1, and level 3. All of those different topics would be received with that simple subscription there. So let's also have a look at that in practice. So we'll jump back into the broker and my client. We'll just set that up again. Get my connection. We'll do a clean session this time. That's all ready to run with its 10-minute window. So now on here, I'm going to do a subscription. So I'm going to subscribe, and I'm going to subscribe to sensors/plus/site1 with a quality of service of 1. That's all done. Subscription is in place. We look on my client. Give that a second to refresh, and here's my new subscription that has arrived. So now if I publish a message, let's just edit the topic that I'm publishing to, sensors/temperature/site1. I'll just send hello world again, publish that with quality of service 1. If we look on my client, then we'll see that the message will arrive momentarily. We'll also see here on the broker that the queued message count has moved, and I now have a message in flight. So that was that message that was sent to the temperature value in that wildcard. Similarly, in here, I can send a message, and I can change that to sensors/light/site1. Send another hello world message to there, and we'll see that that message will now come in and get queued for my client in here as well. If I now go and publish that message to sensors/light/site2, then we'll see that that message will not be queued here. I'll fire that off, and my queued count will not increase because it's gone to site 2, not site 1, which is the one that I'm subscribed to. Let's clear those queues out, and we'll set up a subscription now to the other wildcard level. So let's say sensors/hash. So this is now saying, subscribe sensors/hash, service of 1. So now if I go back to my client, I'll have a new subscription will arrive in a second for sensors/hash. And now if I publish a message to sensors/light/site4, then we'll see that message will get queued up for this client now. Now that it's subscribed to the deeper wildcard topic. And similarly, I can say sensors/all/site4. Publish my hello world message, and that should now come through into the client. So let's move on and have a look at quality of service. The guarantee of delivery is defined by what's called quality of service, or QoS. Mqtt has support for 3 different quality of service levels: quality of service 0, which is fire and forget; quality of service 1, which is to deliver at least once; quality of service 2, to deliver exactly once. And we'll have a look now in a bit more detail at what that actually means. So quality of service 0, at most once. This is used to ensure that the message reaches its destination no more than once. So the client will publish quality of service 0, the Mqtt broker will receive that message and immediately send it on to any clients that are subscribed to the topic. There's no message back to the client. The client's not expecting any acknowledgements. It won't try and resend that message. So key features, it's best effort message delivery, no acknowledgement back from the recipient, no retries. It's not queued. So if you publish a message at quality of 0 and there's a client which is subscribed but not connected, then that message is not queued for delivery. So an important thing to remember when we talked before about possibilities of having message loss if you don't manage your connected state appropriately. That's one instance where you could not receive messages that you might be expecting. So it's good for power constrained devices, minimizing their time on air. It also minimizes the cost of any messaging because there's no kind of handshake going on. And it's fine to use in cases where your message delivery is not critical. So if you imagine a sensor which is sending soil moisture data very frequently, if one of those messages didn't arrive, it's not the end of the world. You don't need to be guaranteed that that message turned up. Looking at quality of service 1, this is delivering the message at least once. The sender will store that message until it receives an acknowledgement back from the recipient. So here we have the message going out with its publish. The Mqtt broker will receive it, respond back with an acknowledgement, telling the client that it's all done and it's okay, and will immediately deliver that message on to the subscribed clients that are sort of listening on that topic. If you imagine a case where maybe this pubAC is lost, the client will retry to send that message and the broker will deliver it on again as soon as it receives it. So this is where that kind of duplication of data can happen. So it guarantees a message is delivered at least once to the recipients. The sender will store the message until it gets that pubAC back, and this means that message could be delivered more than once. So when you want to use it is when you have to receive every message, but you have some kind of handling on the recipient side for duplicates, or if duplicate data doesn't matter. Use it if you want messages to be queued up. So if a client is disconnected but subscribed, then as we saw earlier, the message will go into the queue for that client. And you would use it when the overhead of quality of service 2, which we'll look at in a second, is too high for your use case. Quality of service 2 delivers that a message is delivered exactly once. In this case, there are 4 different handshakes in here. There's the initial publish with the quality of service of 2. The broker responds with a received message. The client will then respond back with a release. So this tells the broker, okay, I've got your received. I know you've got it. So now please go ahead and deliver that message to the subscribed clients. And the broker then comes back with a completion message. In the event that this receipt message isn't received on the client will retry the publish, and it will have a retry indicator set, which the broker will recognize and respect. It will send the receipt message back again, and it will hold on to that message until this release message comes back from the client to say, right, okay, you're good to go. You can go ahead and deliver that message now. So in that way, you're guaranteeing that the message will never be delivered to subscribed clients more than once. So it's the safest quality of service level, but it's also the slowest. There are 4 handshakes in there, quite a lot of information flowing back and forth that all has to be received for everything to work. So we would use this where your message delivery is critical and any duplicate data would be harmful to the subscribers, that they're not geared up to deal with potential duplicates. So that's MQTT and the basic principles of the core protocol. Let's have a quick look at Mqtt Sn and how that differs. In Mqtt Sn, there are 3 different additional features, all of which are designed and optimized for power and bandwidth constrained environments. The first one of those is topic aliasing, which allows you to reduce bytes over the air. So if you think back to our example topic structures that we were looking at, when you're publishing to those topics and subscribing to those topics, you need to send the whole topic name over the air. With Mqtt Sn, you can predefine these on the broker. So if we look in at my ThingStream broker here, if I look in the topic section, I can see a number of topics that have already been set up. I've set one up here for sensors/heat, and I've assigned that a topic alias 114. So now when my client wants to publish to sensors/heat, it can simply publish to 114 instead of having to send those additional bytes over the air. So you can save yourself quite a bit of additional data and therefore power on the device. There's also a sleep mode. So we saw in the main MQTT example, when a client is disconnected, messages published at a quality of service of 0 will not be delivered to it. They just disappear. With SN, the client can disconnect but set a duration to tell the broker that it's effectively going to sleep for a period of time. And during this time, the broker will queue any messages regardless of the quality of service level and deliver them back to the client when it wakes up. There are also an additional quality of service level, a quality of service of -1, which we refer to as a blind fire and forget. This works in terms of handshakes in the same way as quality of service 0, but the client does not need to be in a connected state in the first place in order to publish that message. So just in summary, you have predefined topics, allowing you to create that topic on the broker first to save yourself billable messages and time on air. The long topic name never needs to be sent over the air. You're just doing it with just that simple integer. And when you're not using predefined topics, SN clients have to register the topic that they want to use and get a reject back. So there's 2 additional messages and handshakes that need to happen when predefined topics are not used. So with quality of service -1, perfect for low power, non-critical data. It doesn't matter if every message gets exactly where it's going. You're sending frequently, and if the odd message doesn't arrive, it's not the end of the world. You're just really interested in saving that power. So you've got the publish of -1. As soon as that message arrives at the broker, off it goes out to any subscribed clients, and the device can go back to sleep. Looking at sleep, as we said, the Mqtt Sn client can say it's going, it issues a disconnect with a duration value, and the broker will then maintain that state for the period that's been specified and queue up any messages while the client is asleep. The client would then issue a ping rec to the broker, and if there are queued messages, the broker will respond with a publish and then finish off with this ping resp message, ping response, to say that it's all done and the device is safe to go back to sleep. Whenever there is communication from the client, that sleep duration counter is reset. So if you had a 1 hour sleep or something like that, the client can wake up at any time during that 1 hour window, and then once it goes back to sleep again, that 1 hour is reset and the timer starts again. So let's have a look at doing some of that quality of service -1 and predefined topic messages, and we'll have a look at sleep mode as well. Let's just go back to my my client, just close it down and reinitialize it once more. That's all set to go. So I'm going to try a predefined topic publish, and I'm going to do that at a quality of service -1, so I don't need to connect first. So the first thing I need to do though is just set up my predefined topic on the client, and I want to define that as sensor. Let me just double check the exact syntax: sensors/heat, and I'm going to give that the alias 114, same alias that was created here on the broker. That's done. My predefined topic is now known to my client, so I can use it. So now I'm going to publish a message, and you'll note that let's just hit that disconnect on there. So my client is not in a connected state. I'm going to publish the message to sensors/heat. And I'm going to say hello. I'm going to publish that with a quality of service -1. So my client has now published that, sent out on sensors/heat with a quality of service -1. Underneath the covers, it's replaced sensors/heat with 114. So that's all that's gone over the air. And if I look now on my client in my received message, then I'll see here it is, sensors/heat. It's come in, and it's come in with my quality of service -1. So that's all in a disconnected state as far as the broker is concerned. Let's have a look at how sleep mode works. So if I connect now to the broker, I'll give it a clean session, set my keep alive. I'll come in and I'm now connected, and we'll see in a second. Here's my UI is updated with the connected state. If I now sleep and set my duration for 60 seconds, the client will now go into a sleep mode, and we'll see the state now has updated here to sleep with a keep alive of 1 minute. This client will issue a ping every minute to refresh that window. If I publish a message, I have no subscriptions. So let's just connect. Subscribe to webinar. Sleep again. Come back to here. And see once that does a refresh. Here's my subscription to webinar. My client's in a sleeping state. So if I use my test message to send that to webinar, I'll send hello world again. This time I'm going to send it with quality of service 0, which would normally have been discarded because I'm not connected. But in this case, we'll see that the message is queued. It will go into the queue and wait for the client to wake up. And if I now go to my client and wake it up to send that ping, then we'll see the messages will be delivered. So it's now gone from the queue, and we'll see here on my client, the message has been received. Quality of service 0, hello world, and you'll see now that everything's gone back to sleep because that message has been delivered back down. The client's all finished. It got its pub rec message. If we look in the traffic log, we'll see there's the publish and there's the ping resp in response to that sleep and wake process. So yeah, that's how all of those bits work. So now we've talked about how Mqtt Sn can save power. We've looked at how using predefined topics and sleep mode can help you reduce the amount of data that you're sending over the air. And we've talked about Mqtt being a lightweight protocol. But you need some numbers and data to back up those claims. So Hamid now will talk you through some of the power testing that we've done and show you some of the results of how power efficient Mqtt Sn really is. So over to you, Hamid.
Thanks, Nick. Hello, everyone. Good morning, good afternoon. So my name is Hamid Siasi, uBlock Services Solution Architecture Team. Well, in the coming 10 or 15 minutes, I would like to talk with you about the power benefits of Mqtt Sn. I'm going to share with you the results of the power measurements, power profiling that we have done, and then basically let the numbers do the talking. Well, we got a simple scenario of pushing or sending 200 bytes of data from the field to the cloud. It's a simple scenario, but can represent a lot of IoT apps. And in terms of the test setup, we used uBlox SARA R510S module AVK. As you probably know, R5 is uBlox LTE-M and narrowband module with secure cloud. And I have used uBlox Thingstream IoT SIM card, which can provide global roaming and therefore can enable my setup to connect from almost everywhere in the world. This test has been done in UK and with the Telefonica O2 LTE M1 network. This is also important to mention the network because each network operator has its own setting, for example, inactivity time and etc., which can affect the result of the tests. And I'm using OT Power Analyzer, which is quite known in embedded world. Next slide, please. Thanks. Okay, so before talking about power measurements and power consumptions of a cellular-based solution, I think it's good to just refresh about the various sections of a connection and messaging process of a cellular-based solution. And of course, what are the power consumptions associated with each of them? Here you can see a screenshot of the power analyzer, and you can see the first phase, which is powering on or booting from cold or PSM power save mode. And then we got the scan and registration attaching to the network, and then finally releasing the RRC and going to idle mode. What I would like to demonstrate here is that independent of the application, independent what you want to do, there is a fixed amount of the works needs to be done. Powering on, connection, attaching to the network, and then cleaning up everything and go to idle mode. Using URCs and the greeting messages, we were actually enabled to measure the power consumption associated with each phase. Next slide, please. So yeah, we have seen that, for example, for the booting from the cold, we are spending 95 microwatt hour, and for scanning and also RRC release and etc. What I would like to mention here, highlight here, is that there is a fixed cost in terms of power consumption, independent of the application. But it's not all. The overall cost depends also on the messaging. So there is a fixed part and a variable cost depending on the messaging. On the fixed part, well, once we have decided our network operator, we can barely optimize more, and the numbers are more or less there. In our case, the fixed cost was 192 microwatt hour. But the variable cost, which is depending on which protocol you want to use, how you want to secure your data, what is the security mechanism that you would like to have, what is the quality of the service that you want to have. This is actually the part that I would like to focus. We are talking about the cost of messaging, the part that we have actually control of that. Next slide, please. So power consumption comparison, pushing 200 bytes of data. As I mentioned, I'm not actually considering the boot and network attach in these numbers. It includes everything, but not the fixed cost that we have seen. In my case, in my measurements, it was 192 microamperes. Let's start with the first solution, with the orange one, which is using Mqtt Anywhere. Mqtt Anywhere is uBlox service based on Mqtt Sn, and the quality of the service -1, as mentioned by Nick, it is blind, fire and forget. There is no connect, disconnect, no acknowledgement. You just send a message. You can see that, yeah, the power associated with sending 200 bytes is 44 microwatt hour. But what if you want Let me just highlight before going there that the security in Orange solution is based on the APN, private APN. Just to recap, APN is a gateway for a cellular device to enter to the IP world. And having a private APN, it means that you are not actually going to touch the internet, wild internet. So your data is secure. But if you want, I'm talking about yellow solution, the second one. If you want to have also your data be encrypted, we have said that we are using a private APN, so your data is secure, but you want to encrypt it as well. You want it to be end-to-end encrypted. This end-to-end is a service that uBlocks is providing as a security as a service. So we can encrypt the message inside the device, inside our module, and then the same message can be decrypted in the cloud part without going to the whole part of the handshaking part in order to get to the shared key or symmetric key. So it is much more efficient than a normal TLS or DTLS. Yeah, you can see that there is a cost for this encryption in the device, and so the messaging cost arrives to 60. I can raise the quality of the service to 1, and in this case, you need every message to be sent at least once, and you can handle also some duplication. This is the green, light green solution. You can see easily that that the amount of the energy consumption is going up because of, and now you are actually dealing with a quality of service 1. So we have both connect and disconnect, and we are sending the data, and we are also encrypting the data. So yeah, there is also a cost associated with that. But what if I go and use Mqtt Sn, the standard version, and also as a security mechanism, I go for DTLS, which is TLS on top of UDP. Quality of the service -1. First, this is the brown, dark red, I can say, yes. This one, yeah. Solution. First, you can see that, yeah, the energy consumption goes up, but this is not the only negative side. You are also dealing with a sort of uncertainty. You cannot completely predict what will be your final energy consumption, because it depends also on the network. You are doing the whole handshaking stuff in order to get to the shared key, and it means a lot of flights between the device and the broker. So we have a best scenario and the worst scenario, how lucky you can be in terms of your connectivity. So you have a range here. And if we go for the quality of the service, we raise the quality of the service to 1, and this is the brown one. Again, the energy consumption will go up. But what if I just switch from DTLS on top of UDP, which is a connectionless if you want, and go to TLS? This is actually MQTT, and the quality of service is 1. This is dark green solution. You can see that still the energy consumption is going up. So the range is something between 300 to 1000, and what I have seen in the most of the tests that we have done, we are actually getting something around 500. So again, the energy consumption is going up. And as you can expect, the worst solution that maybe you can decide here is, and if you want, it's the pink or orange one, is the HTTPS. So here we are using TLS, and we are dealing actually with a protocol which is designed for web technology, not for IoT. It has a lot of overheads and etc. that we don't really need to deal with them. On the other hand, the whole mechanism is different. In the MQTT, we got the push and subscribe mechanism. Here it's RESTful. You request something to get it. So what I would like to demonstrate here, coming back to the first topic, about the power consumption related to the messaging. It depends on what we decide to use in terms of the protocol. If we go, for example, on MQTT Anywhere quality of service -1, or go to HTTPS, you can see that each time we are sending a message, something like 200 bytes, how much is the difference of the data, the power consumption? And you can only imagine that what will be the effect on your battery lifetime. But power consumption is not the only cost. There is also, how much traffic you generate over the air. Using some AT commands that we got, we can count how much data we are actually sending or receiving. Again, you can see here with the MQTT Anywhere, the service that u-blox provide based on Mqtt Sn. For sending 200 bytes of data, we are only sending 235 bytes over the air. And considering that the quality of the service is -1, so you don't expect to receive any confirmation acknowledgement, you don't receive anything, no received data. Rising the quality of the service, okay, you expect to receive some acknowledgement, then we have 66 byte as a received data. Changing to Mqtt Sn with DTLS, you can see that now you can see the effect of the handshaking step of security. So you can see that we got around 900 data sent and 3,300 received. Going again to TLS, changing the whole UDP to TCP this time, again, you can see that everything is becoming double. And the worst solution that you can go is, as usual, is HTTPS, and you can see that the number is so high, 6,600. Just compare it with 0 in the first solution. So what I would like to, if I want to summarize, I want to highlight is that the overall cost of any IoT solution, just for example, sending 200 bytes of data, part of it is fixed. It's more related with the network. It's more related to the fixed amount of the works needs to be done. But part of it is it's a variable cost, and it depends on actually the architecture and on the design, and which protocol you would like to go, which service you want to use. We have seen that MQTT Anywhere in my tests is outperforming other IoT solutions by significant margin, both in power consumption and also in data over the air. Of course, if you want to have access to the full numbers and etc., we are more than happy to share all the results with you. I hand over to Bruce.
Thank you very much, Hamid. That was great. So just a quick summary, and then we'll go on to answer the questions. Next slide, please, Nick. So first of all, just to recap there, MQTT has really over time become the lingua franca of IoT. It's had very widespread adoption for many companies, and it's very easy to obtain client software for MQTT. It's lightweight, it's easy to implement in solutions, and it also gives you a choice of flexibility when you come to think about radio network, and that's reflected in the products that u-blox offer across our different product ranges. The MQTT Anywhere solution here and now designed for cellular, for Wi-Fi, and for LoRaWAN. You can get more information on the u-blox products at the link we've got here, or if you want to talk more detailed on any of these subjects, please do feel free to drop an email into support@thingstream.io, and one of the team will help you out with those questions. So moving to the questions that we've actually had in the session today, there have been some interesting ones. Yes, just some housekeeping there. We are going to make the slide decks available to everyone, yes, and also the video for the video of the webinar will be sent to you automatically as a registrar to this, so you will get those after following the presentation. Next question: if there's a loss of connectivity between the client and the broker, after how long is the link broken or cleared? that is up to the client. The client can specify what it wants to do about timeouts. You can specify those things, and the client will typically reconnect after whatever period of time that you specify. So it's not mandated into anything. It's up to you. I think we've dealt with the quality of service -1 question. What can you say about losing the other two communications from quality of service 2? I assume this question is asking, why would you use QoS 2 versus the other protocols? And really the answer is whether you need it. In practice, we find that for most customers who are not looking for, don't necessarily need to have that guarantee of single once and only once delivery, you don't need to worry about it. And in fact, the extra overhead involved in it is probably unnecessary for most solutions. Not to say there won't be cases where it is, but it certainly is not the usual case. It's more of an outlier for certain particular uses. Is MQTT suitable for high frequency sensors? I think the answer to that question is it all depends what we're talking about in terms of high frequency. In general, there is no restriction really in the frequency at which you can send or receive messages from a broker. Those are usually limits imposed by other things, either typically the type of hardware you're using or the network connectivity rather than the broker itself. So it may well be suitable, but it really depends on exactly what you're talking about and the use case there. But there's no real reason why it shouldn't be usable in those kind of scenarios. If the client wakes up prior to the expected sleep duration, this is obviously an Mqtt Sn question, will the broker still attempt to flush the queue or only at the time the duration has been set? Yeah, it will do what you would hope it does. So when you set the disconnect with a timeout, what that is actually saying is to the server is that you can discard the messages if I don't come back to you within that time period. So you can come back and ping at any point before then, but once you hit that timeout, then the server is free to clear the queue of messages. So yes, you can do what this, you can come at any point before that timeout and you're all good. Monitoring summaries, heart rate and blood pressure. Yes, that's certainly a good use case for this. And in fact, to the point that I think Nick was talking about topic structure, it can be really useful because you can potentially, where you have a sensor that is sensing multiple things like heart rate, blood pressure, etc., you can send all of those in a structure that both associates it with the individual patient, but also then perhaps differentiates those by individual sensor subtopics, which you can of course filter and create alerts for. So you could, for example, have obviously general patient information being processed in one way, but for example, you could have, say, a specific process set up to monitor all patients' blood pressure, and if any one of them drops below some point, to generate an alert on that. With the combination of publishing data using the correct structure of topics and also then the topic wildcards, you can introduce processing that will deal with that very effectively. Are there any investigations on decentralized network for MQTT? I guess that means about having multiple brokers, maybe. I'm not quite sure. If you could be more specific about your question or ask or send us an email, we can perhaps give you a better answer for that one. Will the webinar be available on YouTube as well? I don't know the answer to that question, if I'm totally honest. I don't know if one of my colleagues on the call does know the answer to that.
Yeah, yes, it will, Bruce. It will be on YouTube.
Perfect. Thank you, Andy. Lovely. There you go. So yes, that will be available on YouTube. Thank you. In the case I'm using only uBlocks modules, do I need to use uBlock servers? No, the modules, the MQTT clients in the modules will work with anyone's brokers. We've certainly tried it and tested it with a number of different things, like, for example, Amazon's AWS Mqtt Broker. The one thing I would say is that some of the modules support have integrated Mqtt Sn clients, and in that situation, I think we are one of the few companies who, maybe the only company, who has a commercial cellular Mqtt Sn offering in the market today. So that is going to be something different, but it's not something you're tied into. The implementations of the client and server are independent from each other, and you can interchange them quite deliberately. How does a keep alive timeout work with the power consumption of the sensor client? Does the client always need to send ping requests before timeouts? I think there's two different questions in here. The first of all is the keep alive period. So obviously the client and the server have some view about a keep alive, and in order to keep the connection up, there has to be a regular sort of ping just to establish and make sure that everything is still alive. But in the case of Mqttsn, if you do a disconnect with a timeout, that's a different matter. What you're telling the server there is that you are basically going into effectively a deep sleep mode. So you are going to be, to all intents and purposes, off as a client. And you're requesting the server then to preserve your messages until some point in the future when you reconnect. Now that obviously has no impact on power because you are effectively assumed to be offline, and the server has the responsibility of maintaining the messages until you come back out of deep sleep and do a ping where you'll get your messages sent to you. I hope that explains the questions. Next question, are there limits on message size? Not practically, no. There are no limits within the protocol itself, although different brokers will implement different caps to that. But technically, the standard doesn't impose any upper limits. Of course, having said that, you have to consider often things like the radio network that you're working with and what is a reasonable limit to place on something. So if you know, for instance, you're dealing with MQTT on LoRaWAN, you have to consider how big you really want the messages to be, because otherwise you're going to find they just don't work. And that's often something we suggest to customers who are thinking of using perhaps or have a need for wanting to send bigger messages. For instance, like a firmware update. There's no reason at all why you shouldn't have a topic dedicated to firmware updates that all the clients subscribe to. But in situations like that, it may be better to send a series of messages that represent fragments of the upload and allow the client device to reconstruct those fragments into a whole rather than sending one single huge message. So that's our recommendations there. Dealt with that. How about quality of service between the broker and the subscriber device? I'm not quite sure what that question is asking. Are there, so I'm unfortunately
maybe it's about the downgrade of quality of service.
Wait, would you like to speak to that, Nick?
Yeah. So so when a client publishes a message, it obviously specifies the quality of service that it requires in terms of what it needs to know about that message being delivered, and you know, whether it matters if there's a potential duplicate or not. From a subscription point of view, the receiving client might not care about that. So you could have, for example, a message published at quality of service 2 delivered to a subscription of quality of service 1. So the delivery of the message will always be done to the lowest quality of service that applies. So if you had a message that was published at quality of service 0, but you were subscribed at quality of service 1, then that publish back to you would still be at 0. So you can't upgrade the quality of service, but you can downgrade it based on the needs of the receiving client.
Very good. Thank you, Nick. Next question. Are there any issues scaling up from proof of concept to full field implementation to thousands of devices? No, not at all. Many MQTT platform vendors, including ourselves, have accounts at free tiers that allow people to try out the services and then move from something that's small to something large. Certainly talking on behalf of uBlock Solutions, obviously we've designed the system to scale based on demand, and you know, we've supported communities of millions of devices sending billions of messages. So it is not a scalability problem to move from proof of concept to full deployment. Have you plans to offer lightweight M2M services in the future? I believe it's still a valid alternative to MQTT. It may be for some use cases. Our own testing between the two demonstrates that Mqtt Sn in particular pretty much beats lightweight M2M in all aspects of data and power consumption. And from a developer's point of view, there is also an awful lot more flexibility offered in MQTT than you get with lightweight M2M. Lightweight M2M has obviously come from a particular place. It originated from, you know, if you like, the cellular operator community and their need to manage firmware updates and settings on mobile devices. So it's clear to see what it was designed for and where it comes from. The challenge is when you want to move from that particular use case out into a more industrial use case, you find yourself constrained by a number of things which don't make life easy for you, particularly in the early days of prototyping a solution. So we don't really see there's a great advantage to it. We have thought about the ideas of supporting lightweight M2M within the platform we have, but to date we haven't done it simply because it is just when we actually look through customer use cases and talk to customers about it, we generally find that it's better, simpler, and more effective to use Mqtt Sn for the same thing. So there's the question. Oh, right, that clarifies the question. Yes, about the distributed question was about multiple brokers. Can you work with multiple brokers? The answer is you can work with multiple brokers, and indeed you can connect brokers together. In fact, I think as we were talking earlier in the presentation about what we have, for instance, within the uBlocks platform, within our MQTT offerings, we have elements within the system that allow you to connect MQTT traffic to either other brokers. So, for instance, there's pre-built components to connect you to IBM Watson or to AWS MQTT as well, and also to do a similar thing for other protocols as well. So if you happen to be a customer using something like TIBCO's messaging infrastructure to connect those together. So yeah, you can connect these things together to create different solutions depending on your needs, actually. I think that is the end of the questions there. So thank you very much, everyone, for attending today. I really appreciate it. Hopefully it has been a useful session and that you've learned something from this. Thank you very much.